Alrighty, in this video we're going to look at graphing f of x and f prime of x, its derivative. So we're going to begin with this function where f of x is equal to 1/2 times x squared. And we're going to go ahead and just plot some points here. I'm going to make a real quick t-chart and plug in some values. When x is -2, the output value is 2. And here's a few more points. So here is my parabola, and what I want to do is try to come up with some understanding of what the graph of f prime of x is going to look like. And we want to remember, first of all, what this means. What f prime of x is the it's the derivative of our function f of x. So it is telling us something about the slopes of the tangent lines at various locations of x. So what I'm going to do is go ahead and draw some tangent lines on my function that I've graphed, and we're going to have a little conversation about what the slope of the tangent line is. We're going to start in the middle at 0. And if you look at my blue line, there's my tangent line, and hopefully you agree that the slope at that point is equal to 0. So if I make a simple table here, I'm saying that when x is 0, the slope, or the instantaneous rate of change, is equal to 0. Let's look at another point. At 1, if I draw my tangent line when x is equal to 1, I'm estimating here, but it looks like the slope, well, I'm cleverly estimating, I happen to know, but the slope looks to be 1. It looks to be about a slope of 1, up 1 over 1. If we go up to 2 and draw that tangent line, that slope is a little steeper. The graph is increasing faster at that point, and it looks like our slope might be 2. So let's see what happens with some negative numbers. If we go, let's look at -2 and -1. At -2, my tangent line has a steep negative slope, and because my graph is symmetrical, whatever I said for +2, it's going to be the same for -2. So we're going to say that that's -2. At -1, it looks like my slope of my tangent line is going to be the negative version of what I said at +1, which was 1. So -1. I'm going to go ahead and plot these points, and let's see what happens. So I get this straight line that has a slope of 1, and we should ask ourselves if this makes sense. But before we ask that, I just want to make sure that we're seeing what this is. I have plotted at various values of x, I have plotted output values that represent the instantaneous rate of change along the parabola. So the fact that the left-hand side of my graph for -x values are below the y-axis is indicative of the fact that my slopes on my left portion of my graph, my original graph, f of x, are negative. The slope is negative there, the slope is negative there, negative there, negative there, negative there, and that is what is being represented by these negative y values. The fact that these y values are positive is indicative of the fact that the slopes along this portion of the curve are positive. They're going up. So using our power rule that we've learned about, let's go ahead and find the derivative of f of x. The derivative of f of x using our power rule will be 2 times 1/2, which is 1, times x to the power of 1. So my graph is y equals x, and that is precisely what I have drawn right here. This is the graph of y equals x. So on this line, what I have is a mapping of my slopes at various points. So what I can say, this is kind of cool, because what I can say is, like, when x is 1/2, what is the instantaneous rate of change on my function? Well, if I just look at 1/2 on my curve, I see that my output value is 1/2. And that corresponds with an x value here of 1/2, which is equal to 1/2. So the instantaneous rate of change the slope of the tangent line on my original function f of x is equal to 1/2 when x is 1/2. All right, let's look at another example here. This time we're not dealing with any kind of equations. I'm giving you a curve that I'm calling f of x, and we are going to try to come up with a graph of f prime of x. And so what I would tell you is that there are certain places along a curve that are convenient to analyze. And those most convenient places are where you have horizontal tangent lines. Because you know with horizontal tangent lines, such as at this location, when you have a horizontal tangent line, the slope of that graph is 0. So what I want to do is, at this x value, I have no idea what it is, we're just calling it blue tick mark. At that specific x value, I have an output value on my function f of x that is 0, because I'm trying to map my slopes at various instants in time. So I'm going to go ahead and start with that blue dot there. I know that that point will lie on my function f prime of x. And using the exact same logic, I know that this point has a horizontal tangent line, meaning that its slope is also 0. So if I'm plotting the slopes at various points, I'm going to put another point at 0. So that's a really good start. So let's look at what's going on in between those 2 points now. For this portion of the curve, we're dealing in terms of approximations right now. I can't be very specific, but I do know a few things. I know, first of all, that my curve is going down from this point to there. The curve is going down, so all of the slopes are negative. So on my graph of f prime of x, that means that all of my output values are going to be negative, meaning that my graph is going to be living underneath the x-axis somehow. Now, sadly, I didn't draw a very good curve. It's a little bit wiggly, but if I could convince you that this portion of the curve right here is where my slope is the steepest, if I had drawn like a more standard polynomial curve, let's think about what that means. If this is the steepest downward slope and then it kind of tapers off before coming 0 again, that means that at this value of x, I'm going to be somewhere very negative. I don't know what that negative value is, maybe -3, who knows, but I'm going to go ahead and put at this value of x, my low point on my graph, because I'm saying that the slope is the most negative at that point. And let's look at a few other points here. My slope at this point is still negative. This value of x, it's still negative, but it's less negative. And again, we're approximating, but I'm going to put a point right there. Here it's a little bit more negative than my last point, not quite as steep as it is here, but it's still negative, so I'm going to put a point down here. And then if we play on the other side of this curve too, with this portion of the graph, again, what's happening here is that the slopes are still negative, but the slopes of the tangent lines are leveling out until they get all the way back to 0. So my points on my f prime of x curve are going to climb back up towards 0. So there we have it. That portion of the graph is looking good. Now let's look at, let's go from this red dot to this red dot and ask ourselves what's going on here. And actually, we could look at this entire portion of the graph, because this whole piece looks like it has a slope of about, I don't know, 1 or 2 or 3, something like that. And then it kind of becomes less and less and less and less and less until leveling off to 0, a horizontal tangent line there where we already have that point at 0. So here's what I know. I know that this portion of my graph will give me positive slope. So my graph for those corresponding x values is going to live somewhere up above the x-axis in the positive range. So let's just try plotting some points at certain x values. Let's say right here, let's call that 3 and just put a blue dot up there right around 3. I mean, I don't even have marks on my graph, but work with me. The slope is about the same there. The slope's about the same there. And then it kind of starts at this point to become a little bit less and a little bit less and a little bit less. And what we're going to see is that this curve is going to descend. And I wish I could have drawn that better for you. It's going to kind of curve down like that. Let's leave that there and we'll practice this more.